Can I see the 45 one? Where is it? Trig ratio of, okay. So we started, last time we already started 30 degree and its multiple. Or did I call it 30 degree or pi over 6? Was that what I called it? Can you check? Anyone wrote something? No? Did anyone write this? Just the beginning. I know we didn't complete it. Okay, in case you didn't know, that's fine. So, let's have our unit circle to begin with. Of course, by unit circle, we mean what again?
Oh, you want for angle 45 degrees
Radius
or
of what?
pi over 4?
Radius of.
But that we already did.
Yeah, no, I'm just saying. Continuous. Oh, last time, never mind. You know what I said.
Okay. By unit circle, we mean?
Radius of 1.
A circle with radius 1.
Can you say that again?
A circle with radius 1.
You don't just say radius of 1. Unit circle doesn't mean radius of 1. Unit circle means a circle with radius of 1. Understand? So, the last time we were looking at how to get trig ratio of 30 degree and its multiple. Then we started with 60. Yeah? We started with 60 and we say, okay, suppose our OP makes an angle of 60 degrees and that 60 degree is the same as pi over 3. So 60 degree or pi over 3. Okay, I just write 60 degree. Okay. O is the center and P is that point. Of course, the coordinate of P will be cos theta sine theta. In this case, cos 60 sine 60. Is there a problem? Is there a problem?
No.
Okay. So, what I said the last time, if you remember, is suppose we join this arc. Then I try to justify the kind of triangle that we have. What kind of triangle is this? Equilateral. But in the first instance, it looks like what? An isosceles because of the radius. Yes?
Yes.
And then further analysis shows that if this is 60 and these two are radii, then these base angles will be equal. If these base angles will be equal, it means the remaining 120 have to be shared equally. So automatically this is an equilateral triangle. Again, do not forget that the radius is 1, so this length here is 1. Maybe I could call the origin Q. So OP and OQ are 1 degree each, 1 unit each. And similarly, PQ is 1. We call it PQ. We don't need that because the collateral means all the sides are equal. Hello, my friend Ryan. Okay? Now, the next thing we tried to do the last time is to see what our perpendicular heights will look like. We call the perpendicular height K. My question is this. This perpendicular line, maybe I call this, if I call this R, for example. Is OR a bisector?
Yes.
You sure?
Yeah.
Sorry, PR.
Bisector of the equilateral.
Is PR a bisector? An angular bisector, of course. Which other angle can PR bisect? Is PR an angular bisector? That's the question.
Yes.
Yes.
It is.
Yes.
Is PR perpendicular? We expect it to be. Now, is OR equals to RQ?
Yes.
Yes.
So I need you to answer this question. Statement 1. Please listen, don't write. PR is a median of the triangle. PR is altitude of the triangle. Which other word can I test? PR is angular bisector of the triangle. Which of this is true? Maybe more than one, maybe just one, maybe none of them.
What is altitude?
Isn't altitude just the height?
Oh, it's the height.
I think so.
Oh, okay.
Okay.
I would assume so.
When you go on the plane, don't you hear the word altitude?
Yeah, I heard that, but I'm not sure. But then
So-
I'll plug the triangle.
Median, altitude, angular bisector. Which of this is true about
I think
PR?
Altitude and angular bisector is true.
Yeah.
Altitude and angular bisector.
If you mean median, do you mean the median of that triangle?
What do you mean?
What do you mean?
What does
In
median,
fact, your friend is asking what do you mean?
what does median mean in this context?
Yeah, in this context,
I don't know. You tell me.
median of the triangle.
I have no idea. I know it begins with M for melody.
Oh, sure.
That's all I know.
I mean, if you got unknown context of altitude, I go by some triangle.
Okay, so I'll help you out.
總之第二三嘅啦。
Yeah, I don't know what she's saying, but I agree with her.
Yeah,
Okay, this is what we mean. All the statements are true.
yeah, sure.
A median is a line which when drawn from the vertex.
Oh,
Can I finish? I'm not even done yet. You're already saying, oh. You don't even know what I'm about to say. Please calm down.
oh.
When drawn from the vertex, it meets the other side facing it at the center. If you have a triangle like this, your median could go this way. That line is a median. It's drawn from one of the vertices to the side facing it, such that it intersects with that side at exactly the middle. That's a median. An altitude is a line that you draw from the vertex and it is perpendicular to the line. It doesn't have to be at the middle. Understand? So, if you have a triangle like this is your altitude. Of course, the length of the altitude is the perpendicular height. But altitude is that line. Understand? So when they say the plane is flying at an altitude of 5,000, it means if the plane is going this way, if you are able to draw a perpendicular line from the position of the plane to the horizontal ground, that distance, perpendicular distance, is 5,000 feet or something. Understand? Now, the last one, angular bisector, as the name implies, it bisects the angle. Okay? It bisects the angle. So it's for equilateral triangle, all these three will coincide. It means it's the same thing. Okay? Even for isosceles triangle,
Yeah, fine.
as long as the base angles are here. Because if you have an isosceles triangle such that these and these are equal, there's no guarantee that this is the stuff. But of course, if you draw from here, yes, that line will represent an altitude, a median, and an angular bisector. Okay? Just wanted to chip in that. We're not doing complex geometry in middle school and secondary. That's why some of these things are trivial things that we should have known. So I just thought I'd chip that in. So we talked about this. Consequently, of course, we know this and this will be equal, but we just applied Pythagoras Theorem the last time. Remember? So by Pythagoras Theorem, of course, this will be 1 over 2.
Yeah.
Oh, okay. I think we use the fact of median now. Okay? Because this will be 1 over 2. So by Pythagoras Theorem, hypotenuse square equals opposite square plus adjacent square. Remember that?
Yes.
So the hypotenuse is 1, opposite is maybe k, adjacent is 1 over 2. So 1 is equal to k squared plus 1 over 4, which means k squared is equal to 1 minus 1 over 4. Yes? So my k squared is equal to 3 over 4. Then my k is the square root of 3 over 2. Of course, I don't need plus or minus in this case. Carolina, can you tell me why? Normally, when you find the square root, you say plus or minus square root of something. Why am I not, why don't I care about the plus or minus in this case? 3 seconds.
Because the length cannot be negative.
That's it. Because we're talking about length of side here. And it cannot be negative. Otherwise, there's something wrong. Okay? Yes. Okay. Now, having known the value of k, then we can easily get the sine, cosine, and tan of 30, as well as 60. So I can have two pictures now. One with 60 degrees. Then the other focusing on the 30 degree here. Do you agree?
Yes.
The same level. 1, 1. 1 over 2, 1 over 2. Root 3 over 2, root 3 over 2. The idea of separating the triangle is to focus on the angle separately, individually. Alright? So you will notice that from here, sine 60, opposite over hypotenuse. That's root 3 over 2 divided by 1. That's root 3 over 2. Is it okay to just write root 3 over 2?
Yes.
No need to write over 1, right? Cos 60, adjacent over hypotenuse. Adjacent over hypotenuse. What's that? Tan 60, opposite over adjacent. This divided by this. So that will be opposite, root 3 over 2, divided by adjacent, 1 over 2. So I do root 3 over 2 times what? Yes? On the second side, we do sine 30. What is the opposite in this case?
1 over 2.
And the hypotenuse? So we still get what? Cos 60, cos 30, I mean. What is the adjacent in this case? Ryan, you are not part of this discussion. You are just listening to what people are saying. You are not talking. And you cannot learn like that. I keep saying it. So you get what? Root 3 over 2. Again, we do tan 30. Opposite over adjacent. Opposite, adjacent. So opposite over means divided by.
Yes.
Adjacent root 3 over 2. So you get 1 over 2 times 2 over root 3. And so we get 1 over. Alternatively, you could just do sine tan 30 is equal to sine over cos. Right? And that's the same thing. You will notice these are equivalent. We can match. Yes? We have done complementary angles. Sine theta is equal to cos 90 minus theta. That's evident again. So sine 60 is cos 90 minus 60, which is cos 30. Cos 60 is sine 90 minus 60, which is sine 30. Of course, tan is not the same. Tan should relate to cot. Sine relate to cosine, complement of sine. Tangent will relate to complement of tangent, which is cotan. That is cot, only for HL. Okay? So with this now, we can now have, remember all these are for acute angles, right? And we know about the symmetry. We can now use the symmetry on the unit circle to see how this behaves when we talk about the multiples of all these 30 and 60. Okay? So, and that is the summary that you have in the printout I gave you today. Again, if you don't want to write this in your notes, fine, but this is just to remember the process. Okay? Start with the line at 60 degrees, try to form your equilateral triangle, okay? And you can get this out. If you don't even remember, okay? But it's easy to remember. Now, if you have our unit circle now, I want us to discuss the symmetry. This summary you don't have to write, even if you write this, you don't have to write it. This is already printed for you. I just want to show you how you can use a few of them to determine all of them. So, we begin with 30. So, you can actually divide this into 3. Yes?
Yes.
So, the extension of this will come this way. Maybe I use a different color for that. Then the extension of this come this way. Now, this angle is 30 degrees, and 30 means pi over 6. Yes? The other angle is 60 degrees, and 60 degrees means pi over 3. Of course, this is pi over 2. Now, here, we'll have a symmetry along the y-axis. What do I mean by symmetry along the y-axis? Here. Can you see that?
Yes.
And this will also have another symmetry, like this. Yes? So, which means I could have a reflection of the blue line this way. Yes?
Yeah.
And I could also have the reflection of the red line this way.
Yeah.
Understand? Okay? Now, so once we can get one coordinate, we can get the rest of the coordinates, really. That's the idea, that's the point I'm trying to make. Every coordinate begins with cosine. Yes? So this red one should have been cos 30 and sine 30, right? Cos 30 is what?
Root 3 over 2.
Root 3 over 2. Sine 30.
1 over
1
2.
over 2.
So the reflection in the y-axis means the y value remains the same. Hello? This is the y-axis, right? This value of y is this. It hasn't changed here.
Yeah.
The only thing that has changed is the x coordinate. Maybe x was 2 here. X is now minus 2 here. Which means from here, we can automatically write this one. And what would that be? Negative, comma what?
1 over 2.
Perfect. This and this, they just flip. Because that's for 60 degree, right? 60 degree, cos is half, and this one. So it's just a flip. Meaning what? 1 over 2, comma, root 3 over 2. And the reflection, similarly, will be what? Uh-huh. That's it. Again, we can get the reflection of this. What do I mean by that? Let's have the orange. What's the orange? But not orange as in orange fruit, okay? I know some of you are like, oh my god, I want orange. No.
Pretty sure orange is still in the classroom.
Can you see? This is what I mean. It means this point and this point have the same what coordinate? X coordinate. But the y coordinate is now a negation, right? So with that, Anika, can you help me with the coordinate of this point? Come on, quickly. No time. Dennis?
Root 3 over 2, comma, negative 1 over 2.
We said it has the same x coordinate. The x coordinate of this is the same. You can see it passed through the same x value. But the y values are different. So if this y value is a, this y value will be minus a. And we also did in the in function f of minus x and negative f of x. One is reflection in the x-axis, one is the reflection in the y-axis. That's what we are saying. If you apply all these together, it's easy. Okay? Understand? So Anika, try this one. Speak louder, please. Class, do you agree with that? Yes. Jensen, give me the coordinate of this point.
1 over 2.
Do you all agree with him?
Yes.
Okay, quickly.
Negative root 3 over 2.
Good. King, give me the coordinate of this.
Negative 1 over 2.
Negative 1 over 2.
Negative 3 over 2.
Do we all agree with him?
Yes.
That's it. And these have been labeled before. Okay? Now what are these angles? These are multiples of 30, right? The first one is pi over 6. So in each of these, you have plus pi over 6. Understand? So if you go this way, I'm trying. I think in the paper it's clear. Okay, good. So if I want to get to the black one, it means another pi over 3 has been added. No, another pi over 6.
Yeah.
This is pi over 6, pi over 6, pi over 2, and that is why this is pi over 2. Hello?
Yeah.
This is pi over 6. To get this, you have pi over 6 plus pi over 6. That's pi over 3. To get this, you have pi over 3, pi over 6 plus pi over 6 plus pi over 6. Understand?
Yep.
Or basically, you can say pi over 6 times k.
Yep.
So the first one is pi over 6 times 1, pi over 6 times 2, pi over 6 times 3. This will be pi over 6 times 4. Do you agree? So what is pi over 6 times 4? 2 pi over 3, right? So this value for the next blue one is 2 pi over, can you see?
Yep.
2 pi over 3. Similarly, up to this part, from the beginning, I use a red mark. I know it's a bit messy. From here to here, it's how many pi over 6? 5 pi over 6. So this angle is 5 pi over 6. Okay? And of course, pi over 6 times 6 is what? Pi. So that makes sense, because angle on the straight line is 180. That's just pi. Okay? The next red one will be how many pi over 6?
7 pi over
7 pi over 6. So up to this point from the origin, I don't know where to go through now.
Let's go bigger and bigger.
7 pi over 6. The next one will be what?
4 pi over 3.
First. 8 pi over 6. And when you simplify, 4 pi over 3. So from the beginning, okay, it says go bigger. I'm going bigger. So this is 4 pi over, understand? And so on. And check your paper. Not everything was labeled, unfortunately, but I'm sure you can figure that out. Yes? Okay? So with one of them, you can actually deduce the rest. All you need to remember is actually two of them. Do you understand?
Yes.
If you can, for me, when I was learning in high school, I only remember sine 30. I remember actually one of them. Because I know there are two. It's either root 3 over 2 or 1 over 2. Okay? So because I know that sine 30 is 1 over 2, then I know, oh, cos 30 must be the root 3 over 2. And when I'm dealing with 60, I flip it back. Do you get the logic now?
Yes.
And once I'm able to identify sine and cos of 30 and 60, I know everything that are their multiples in the quadrants. Understand? For the ones that we did not label, it's just the x and y, whatever. Here, what is the coordinate of this point? What is the value of x on the y-axis? 0. And x here is what? Y here is what? -1. And the opposite is at the top. Yes? 0, 1. Similarly, what is this? X is what? -1, and y is? And the opposite is here. Yes? 1, 0. That's it. And tangent is just when you divide. So if I need to know what is tan 4 pi over 3, I just pick the sine divided by the cos. Understand that? So everybody go to the worksheet I gave you the last time. The worksheet I gave you the last time. Bring it out quickly. The worksheet labeled trigonometry or special angles and their multiples. Have you seen it? So now we have concluded for pi over 6. Then if you'll be able to do, just look at the picture on the board and figure out this result. Sine, you can write directly. Cosine, you can write directly. Tangent, I want you to show me 1 over 2 divided by root 3 over 2, something like that. Do you want me to show an example? Okay, somebody said yes, so we do that. Let me pick question D. Question D is pi over 11 pi over 6. Okay? Now, 11 pi is where? How many pi over 6 is this? 8. Right? So you can count. This is 0. 1 pi over 6. 2 pi over 6. 3 pi over 6. 4, 5, 6, 7, 8, 9, 10, 11. So this is what I'm asking. Okay? This is what I'm asking. This is the cos and this is the sine. So which means for question D, sine 11 pi over 6 is equal to what? Negative 1 over 2. I need everyone to respond, if you don't mind. Cos 11 pi over 6 is what? Root 3 over 2. And the last question is tan 11 pi over 6. What do we do now? So negative 1 over 2, yes? Divided by, and that's it. Minus 1 over 2 times 2 over that, and that is minus 1 over. That's all I ask you to do. Read from the unit circle to your picture, okay? You are welcome to label your paper as well. What's that? You finished already? Did you do like that? Did you do like that? Don't show me paper. Did you write the sine, you wrote the cos, and you showed this calculation for tan? If you didn't do that, then you have not finished. If you did that, then you are welcome to relax. Yes. What? We're not here. Yeah, somebody has your worksheet. Is it easy to do? You just need to count how many pi over 6. Okay? When you move around it. Have you found it? If you can't find it, I'll print another one. Then I don't know what you will have to do now. I'll print another one. No need for argument. Let people focus. Trick of special angles.
No, that's, yeah.
But that's it. I thought you said you don't have it. Oh, okay, okay. Oh, okay, I see. So you already started your work previously. Oh, okay. So when you get the friend's worksheet, maybe you write your name on it. Write his name on it. So it's easy to know. Okay, quickly, everybody get to work. Quickly, please. Quickly, please. Are you done, Miss Rita? Okay, Rita, go to the next page. Go to the next page. Try question 3A, question 4A, question 5A.